Welcome to the second video in the Day of Datomic training series. In this video, Stu Halloway turns to the Datomic information model. Stu will cover Datomic's preferred data notation, Eden, along with the fundamental unit of data in Datomic, the datum. Finally, Stu will talk about the Datomic ideas of databases, entities, and schemas.
Welcome back. We are going to talk now about Datomic's information model. The information model of a database controls how you think. And so this is, ground zero for planning how to put information into a system and what kinds of things you're going to be able to ask of the system once you put information in. We're going to talk about notation. Let me say at the beginning that notation is used throughout Datomic to have data in a literal form, but you don't have to use data literals. Right? So if you're using Datomic, then it's going to show up as lists and maps and strings and whatnot in the language of your choice. So if you want to program with the data directly using APIs, if you're using Java, for example, you can say new java.util.hashmap and make stuff. Everything is in terms of data. The notation is vastly more concise than using Java APIs to make the same data, but they're equivalent. We're going to talk about the fundamental 5-tuple of Datomic, which is called a datum. And then we're going to talk about what it means to be a database. Then we're going to talk about entities. Entities, in an important sense, are not real. Right? The reality of a Datomic database is it's a bunch of datums. But if a bunch of datums are all about the same entity, right? If we have lots of datums about Steve, then we as users of the system think about those datums as being belonging together in a logical group. And that group is exposed as a data structure superimposed on top of datums, right? The fundamental reality is datums. But entities expose that data as an associative data structure, right? Something that allows you to do key value lookup. Give me all the keys associated with Steve. Give me all the keys associated with this order, and so forth. And then we're going to talk about schema and how you create schema in Datomic and how you manage schema in Datomic. So we'll start with notation. The notation that's used throughout the Datomic documentation is the extensible data notation, EDN, pronounced Eden. And this is just an example of the extensible data notation. This is a map describing someone's address book entry, right? It has their name and information about them, and then it has an address and a phone number, and so forth. Eden is fairly small and simple. There are strings in double quotes. There are characters, which you won't use in Datomic, but character literals have a backslash and then a character name. There are integer and floating point literals. The integer literals that look just like numbers are machine precision, so longs and doubles. The integers and floating point numbers that have suffixes are arbitrary precision. So 42n is an arbitrary precision integer. Floating point 3.14m is an arbitrary precision double. Booleans are true and false, and nil is nil. Datomic doesn't store nil anywhere. It doesn't use nil, right? Because there are not, like if you have a relational database, then you might say, I have 10 columns, but column 7 is irrelevant for bananas. Right? So when I store information about bananas, that column is just left null. In Datomic, if you don't have anything to say about something, you just don't say it. Right? Because the data model is more granular, there's no need for dealing with nulls. And then there are symbol and keyword types. These are used to name things. Symbols are used in Eden to name programmatic constructs typically. So methods, functions, class names, and so forth. And keywords are names whose interpretation is left up to the programmer. Keywords play an important part in Datomic because they're used to name attributes. So anytime you see something with colon and some name in front of it, the most common interpretation of that in Datomic is going to be that's the name of an attribute. Colon first name, colon order ID, colon SSN, colon whatever. Then there are 4 collection types. Lists represent a sequential collection. So rounded paren, followed by some stuff to be interpreted in a sequence, rounded paren. Vectors are sequential but also randomly accessible. So when you see something in square brackets, you could process it sequentially like a list, but you don't have to. You could efficiently jump to the end of the data structure. Maps are an associative collection. So here you see a map that maps the keyword A to the number 100, the keyword B to the number 90. And sets are a membership-based collection. So here is a set, and sets are in curly braces with the pound sign in front. Here's a set that contains the keyword A and the keyword B. A couple of other things to notice here. Commas are white space. So they're not shown anywhere in this notation. Most people coming from other programming languages like to see their things in their list delimited by commas. That's perfectly fine to do that if you want to. Probably after a couple of weeks, you'll get tired of typing the commas and start leaving them out. And then you'll start leaving them out when you're writing programs in other languages, and you'll be irritated. It is a fact of life. Eden is generically extensible. And so there's a couple of things I should say. I mean, these slides are really generically about Eden. But let me talk about Eden as it's used in Datomic. One important characteristic of Eden for its use in Datomic is that keywords, the idea of naming things, that's controlled by the user, and symbols, naming things that are controlled by the program, and strings, which are just strings of data, are broken out as three different things. If you were doing the same information modeling using JSON, which is by far the most popular encoding that's out there right now, you only have one type to represent all three of those things. Right? So if you have a string like my name, that's got to be a string. If you have a string that represents the name of a function you want to call, that's got to be a string. And if you have a string that's going to represent the attribute name in the database. That makes a lot of the data encoding that we would want to do in Datomic intractable. Right? It's just not possible to encode because JSON is not rich enough. That's why we don't use JSON. We spent a ton of really irritating engineering effort trying to squeeze more power into JSON. And it just didn't pan out. The other thing is that Eden is generically extensible. So anytime you want, in the middle of an Eden stream, you can say pound name, where name is a string that's entirely up to you. Right? It could be pound stew is awesome. It could be pound whatever. So you can say pound whatever. And then the thing after that name is Eden that is intended to be interpreted specially in the context of that name. And the important thing about this is that it's generic in the sense that if I hand you something that's, pound stew is awesome, and then the vector 1, 2, and you're like, well, I don't have a program that knows what stew is awesome means. You can say, oh, here's a thing that was tagged stew is awesome. And you can hand it on to the next person instead of falling over and saying, oh, I don't know what that means. So this generic extensibility allows you to pass data through intermediaries that don't understand the data. And that's important. A lot of mechanisms for providing additional capability end up imposing understanding on intermediaries. Like, yes, if I know what this means and you know what this means, we can talk about it, but everybody in between us has to know how to talk about it too. And this does not have that characteristic. And you'll see in a couple of places in Datomic that this is used so that you can have data literals. In particular, Datomic supports instance in time and UUIDs as data types that you might want to put in a database. And you can write these as data literals using pound inst followed by an instant in RFC 3339, or pound UUID, the UUID in its string form. So that's Eden. Eden is not, front and center in Datomic. It is a concise way of encoding things. And you'll see it, throughout the docs. And if you're making a data file to submit as a transaction to Datomic, you'll find that encoding it as data is more concise than building the same data structure programmatically, like in Java. I mean, imagine what you'd have to do, right? New map, map.add, 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 or have a Fluent API or something like that. The other thing is it's data, right? So it doesn't require a program to run it. So it's something that you can put on a piece of paper and hand to somebody else, and then they can, use it. It doesn't require execution. So we've already talked several times about datums, but let's drill in. A datum is an atomic fact. Nothing gets any smaller than this in Datomic. It's immutable. When you put a datum in the system, it never changes. It's accumulate only. And it's a 5-tuple of entity, attribute, value, transaction, and operation, where operation is true for we're adding this to the system, and false for saying we're removing this or retracting it from the system and saying this fact is no longer true. Here are 3 example datums about Jane. Jane likes broccoli. As of 1008, true. Jane likes pizza as of 1008, true. But Jane likes pizza as of 1148, false. So the net of these 3 facts, if we're at a point in time 1148 or after, how much do we actually know about Jane? Right? After 1148, the only thing we know is she likes broccoli. Right? So if you were looking at the sort of right now view of the world, you would see only that she likes broccoli. And this slide shows you how logical deletion happens without things going away.
It doesn't mean that she doesn't like pizza. It just means that
Then we don't. It means
know anything about pizza.
it means we don't know that anymore. So however you want to interpret that in your application, right? We don't have to have a closed world versus open world debate right now. But Datomic is typically used for closed world systems. So I would say it does mean that we don't think she likes pizza anymore. But really, the domain interpretation is up to you. And of course, when we start talking about Datomic's time model, you can say, well, as of time 1008, what do we know about Jane? Well, as of time 1008, Jane likes broccoli and Jane likes pizza. As of time 1148, Jane likes only broccoli. There is a datum API when you're using this from Java, and it's just 5 accessors. Right? Give me E, give me A, give me V, give me TX, give me added. And then there's a positional accessor. So the positionality of datums is important, and you'll see that in the query language. We take advantage of that. And so the 0 position is E, 1 is A, 2 is V, 3 is transaction, 4 is added. So you can also use a positional API to get to datums. You are very unlikely to use this API. You can, but you're much more likely to be returning maps and sets via using query. So that's a datum. And you just saw 3 of them. A database is nothing more than a set of datums. Right? Logically, a database is an unordered set of all the datums you ever put in. Now, having said that, that's what it logically is. That's not necessarily how it's stored in Datomic, because if you did something naive with that, you would get a system that didn't perform very well. So for example, you could say, you know what? I'm going to go and write Datomic myself. I'm going to create a table in MySQL. It's going to have 5 columns in it. One that's called E, one that's called A, one that's called V, one that's called transaction, one that's called operation. Presto, I now have the logical model of what Datomic does, but it's not going to be efficient. It's not going to allow you to do anything and the kinds of things that you can do in Datomic. And Datomic achieves efficiency with an open source binary encoding called Freshen. It's one of the ways that it achieves this efficiency. The other efficiency that it achieves is that it stores many different sorts. So logically, the database itself is unsorted. Right? It just is a set of datums. But when you want to actually get something out efficiently, then you want it to be sorted. And so Datomic stores multiple different sort orders on the database. It's accumulate only. It is not append only. So append only, most people when they say that, they are implying something physical about what happens. Right? There's a file somewhere that has some stuff in it, and then more stuff happens, and then more stuff happens, and then more stuff happens. And that presumption leads to all kinds of follow-on presumptions about efficiency. Like if I want to ask something about right now, I can just jump to there. But if I want to ask something about history, I have to jump to the back and run through the entire thing. I have to map reduce over the data or something to find something out. So append only is not viable for the kind of efficiency we're looking at. It's accumulate only. We promise that everything's in there. But all kinds of cool stuff is happening under the hood. So append only would be a very naive strategy for doing this job. And it wouldn't have the performance characteristics that you want to have. You can explore datums from the console. So you can go to the indexes tab in the console, and the indexes have names that tell you the dominant sort, and then the next level, and the next level, and the next level. So the AVET sort, this one's on the AVET sort right now. That says sort by the attribute. So all the attributes are grouped together first. And then within the attribute, sort by the value. And then within the values, sort by the entity. And then within the entities, sort by the transaction that put them in. The AVET index, we'll talk more about the indexes later because this is really about performance, and we don't have to go there right now. But the AVET index is for efficient lookup of something by value. If I wanted to say, who in the system is purple, right, then I would go to the color attribute, which would be the first thing in A. So I've now drilled in. And then I would say, V is purple, and then I would be able to get back the entities. On the other hand, the AVET index would not be efficient for saying, what color is this marble? Because this marble is an entity. You'd want to have E first. You'd want to say, which entity am I asking about? And then, what are the other questions? You can play with all the different sorts and see how they work at the console. One thing I want to caution you about is that, as is traditional in tabular interfaces, when you first select something in the console, you're going to get whatever that sort was. But if you go down here and start clicking on the headers, what are you going to get? You're going to get whatever you did, right? So you're going to say, oh, I asked for it sorted by A, but then I clicked on E. Now it's going to be sorted by E. So don't confuse yourself by sorting it yourself if you're trying to use this to sort of understand the sorts that Datomic provides. Now, entities are a view on a group of datums. Because they're a view on datums, datums themselves are immutable, so entities are also immutable. Right? They never change. Entities can be lazy. So I could say, tell me, and in fact, we'll just walk through this scenario. I could walk up to a system and say, tell me everything you know about order 74, that entity. And now let's imagine that order 74 has 20,000 line items in it. It's a really big order. Then the system can immediately say, here's order 74, and not actually give you any of the line items. And then it can lazily provide the line items if and only if you ask for them. And that could be valuable because maybe you don't care about the line items. Maybe you're looking for the order only to find out whether it was filled or not. So you only want to get the Boolean, was this order filled? You don't want to get the 20,000 line items that are associated with it. So it can be lazy. It's lazy because it's immutable. Those two things go hand in hand. Right? If something can change, I can't deliver it to you lazily. This is a super important concept, right? If something can change, I can't give it to you lazily because by the time you come back and lazily ask for it later, what could have happened? It could have changed. Right? So it takes advantage of the immutability to enable the laziness. Entities are associative. So they associate keys and values. Right? This order has fulfilled true. This order has line items, whatever. And in terms of the physical model, it's inferred from all the datums that share a common E. As you'll see when you think about it, entities represent a point in time. Because they're an associative view, the ability to keep track of time falls away. And you'll see that in a second, you know what I mean. And because we have indexes in every direction in Datomic, entities can be navigated bidirectionally. So, here we have the same three datums we had before. Jane likes broccoli as of 1008. Jane likes pizza as of 1008. Jane likes pizza not as of 1148. The entity view of that is there's a DB ID. So that's a DB ID is a special name. That's the name in entity land that represents the entity that we're talking about. And then Jane likes broccoli. So an entity looks like a map, and notice that it's even printed as a map. Right? The Eden notation for it looks like a map. So it says Jane likes broccoli. If we knew more things about Jane, Jane might also have height or education or whatever else we were tracking about Jane. Why doesn't it say anything about pizza? Well, I'm assuming that this entity is as of 1148. So as of 1148, we don't know anything about pizza. But the fact that it's associative makes it impossible for entities to talk about time. Right? The keys are the attributes and the V's are the values, and there's no place to put the T's. Right? So it can't talk about time. Now, a lot of the time, I'm using that word twice in a sentence now, it's getting awkward. A lot of the time you don't care about the time. You're just like, tell me about Jane as of some point in time. So really, I should say it a different way. Entities already have baked into them what notion of time they are. You have the database as of a point in time, and then you say, give me Jane as of this time. And time was already frozen before you went in. So a lot of scenarios, you don't have to care about this for very much. And when you do care about multiple points in time simultaneously, you can't use entities. Because there's no way that an associative structure can represent that. The entity API is dead simple. Given a database, you can ask for an entity. And you can pass in the ID of the entity. That's going to return an entity interface. The entity interface has get, which takes a key and gets some that represents an attribute and gives you that value. It has touch. Touch is really primarily for development time use. Touch says, I'm done with this lazy stuff. Give me everything right now. And key set returns all the keys that the entity has. How many people have worked with object relational mapping? Right? So the thing about object relational mapping, people say things like, they use this awkward turn of phrase, impedance mismatch. Right? You have a database over here, and you want to make objects over here. But the in-between requires developer effort and thought because the shape of the database does not have a mechanical translation to the shape of objects. It forces choices on you. Right? If the database has a join table, you have to say, well, did I represent that join table with inheritance? Do I represent it with containment? What am I going to do? This relationship between datums and entities is purely mechanical. There are no choices to be made. Because there are no choices to be made, everything that makes ORM terrible with a relational database makes datum to entity mapping okay, not a problem, with Datomic. This is a point usually where somebody runs out of the room and starts building a system. Right? Because this is a big deal. It's a big deal. I'm not saying that this solves every problem about representing things in the programming language of your choice, but it solves a big one. Right? How do I mechanically transform what's in the database to what's associative? And what makes this possible in Datomic? What's the unique characteristic here, or the special sauce? It's the fact that datums are granular. Right? That datums are granular enough that you can make a mechanical translation. Relational databases are not granular enough. Right? They have these bigger things that then involve join tables, and that forces you to make choices. So it's the granularity of datums that make entities possible. The other thing that's nice about entities is that obviously you can say, given Jane, give me the things that she likes. So this is what it would look like to say, give me Jane.get likes. But we know the other things as well. Like we know that Jane has relationships to things out in the world, but we also know that things in the world have relationships coming into Jane, where she's the target of a relationship, or that might be true. And you can say that without extending the API by just putting an underscore in front of the attribute name. So this says navigate the relationship backwards. How many of you, when you're doing object relational modeling, have ever had two different classes and you had to make the decision, am I going to have a relationship from this one to this one, or from this one to this one? Music Brains is a good example, right? Do musicians have tracks and albums, or do albums have musicians? And in Datomic, the answer is always you get both directions. Again, this goes back to the underlying model of datums, right? Going from E to V through an attribute gives you one direction. Going from V, the value, back to E gives you the other direction, so we're done. This gets rid of painful modeling choices. Like, oh, if I go this way, my navigation is fast, but if I go that way, my navigation is slow. So I don't have an index that goes back in that direction. You can browse entities in the console. Anytime you click on an entity, you'll see that entity and then an associative view. And this associative view of the entity just lets you navigate. It's just like calling get, right? The UI is calling get for you. Entities can be named with keywords. You'll see that these entities don't have numbers. They have keyword names. We'll talk more about that later. Now I want to talk about schema. It has become fashionable in the NoSQL era to poo-poo schemas. To say, my database is schemaless as a sort of term of praise. The fact is that schemas, and this first bullet is not about Datomic, this first bullet is about schemas, period. Schemas add power. So whenever somebody says, I have a schemaless database, what I hear them saying is, I have a powerless database. Now, they add power and they also add constraint and cost. So it's not like they add power and there's no trade-off to it. They add power and there's cost to it. And so the reason that people came to hate schemas is that they found that the cost-power trade-off of relational schemas got to be a pain in the butt for some kinds of scenarios. Right? If you're building an inventory database where items in the database might have one of 10,000 different attributes, but for most of those values of attributes, they don't have any. That does not fit a table model very well. Right? Because what are you going to do? Are you going to make a table with 10,000 columns and then say that 9,800 of them are nullable and then have them be null most of the time? So there's no doubt that, but that said, there's no doubt that schemas add power. Right? The relational schema in a relational database does things like say, you know what? You can't have an employee until all 10 of these fields are filled out. I won't even let you put it in the database. This presumes you actually don't have nullable columns. Right? So there's no doubt that schemas add power. And so it's important to consider what powers you're getting and what expenses you're making. The other thing about schemas is it's often the case, again with relational databases, that schemas get in the way of agility. So they provide a bunch of power which you like, and then on day 180 of your project you need to make a schema change. Oops. And that schema change is difficult to manage, or it's expensive operationally, or it requires downtime, or whatever. So I want to talk about what schema is like in Datomic. First, schema is plain data. There's no separate schema API. The way schema gets into Datomic is plain old transactions like anything else, which means that all the tools you use to manage data for everything else you do, you can also use to manage data for your schema. So schema elements are installed via transactions just like anything else. The other thing, and this is to the agility point, is that you can make history-compatible schema changes at any time. So if you decide, I don't like this choice that I made in the past, and I want to make a different choice, and that change of choice is compatible with keeping a consistent record of history, then you can make a history-compatible change anytime you want. And we can talk more about what would constitute a history-compatible change or what wouldn't. But this is really nice because it makes the database capable of moving along with your application model very incrementally. Right? You could end up shipping a system where you enhance the schema with every release and not have that be an incredibly costly thing. Most schemas involve considering the following things for your attributes in your system. First, let me say, right, there aren't tables in Datomic. Right? There's just one universal relation. So the only thing you're going to be saying in Datomic schemas is characteristics of attributes. So in EAVT, what do the A's look like? And these are the things you're going to end up wanting to consider. DB ident is a programmatic name for your attribute. Right? Attributes are entities just like any other in the system. And so from the system's perspective, you're going to put in something like person first name, and it's going to be like, yeah, that's 1011. Right? That attribute is 1011. But you're not going to want to program with the number 1011. So one of the attributes you're going to set on every schema element is a DB ident. That's your programmatic name. You're going to use namespaces for that, and namespaces are delimited by slashes. So you're going to have user/first name instead of just first name. The next thing you want to say about your attribute is its value type. So is it a string? Is it an integer? Is it a UUID? Is it an instant in time? And this is the only sort of structural control that Datomic enforces. Right? Datomic is going to say, well, if you said users' first names have to be strings, then I will reject transactions where user's first name is a number or a date. You're going to be able to say for every attribute, and you're going to have to say, what is the cardinality of that attribute? So can a given entity have one of those or many? So if you're going to say user/friends, is that a cardinality many or a cardinality one attribute? That's many. And hopefully, in fact, people do have more than one. Right? If you were going to say user email, cardinality many or cardinality one? Probably many, right? People have many email addresses. If you were going to say user primary email and have that be the key that you use to find people in the system, then that's going to be a cardinality one. For an attribute, you're going to specify db/index. I told you before that Datomic creates lots of different sorts for datums. There's one sort that is not created automatically, and that's the one that allows lookup by value, AVAT. You can turn that one on with db/index true. I recommend turning this on across the board. When we first started work on Datomic, we were concerned about the performance implications of recording this. It's more expensive to create than the other ones. We have become convinced, based on the last 2 years of operational experience, that the likelihood that you'll be like, oh, I forgot to put that on there, and I wish I had it, and then you have to put it on there, being a pain, dominates the cost because the cost turns out to be small based on our operational experience. So I would recommend setting db/index true across the board going forward in Datomic. db/unique specifies the uniqueness characteristics of an attribute. And there are two choices here, db/unique value or db/unique identity. db/unique value says there can only be one entity in the system that has this value of the attribute. And if you ever try to make a second one, throw an exception. db/unique identity, this is cool, says there can only be one of these, and if you ever try to make a second one, just merge it with the first one. And so people call that upsert in some systems, right? I want to talk about the person whose key is this social security number. If they're already in the database, add facts to that thing that's already in the database. If not, make it. And so you'll almost always use db/unique value for some of the key attributes in your system. Finally, db/is_component says that one entity owns another through an attribute. And this is used to guide things like what things get returned from queries. It's also used to guide things like deletion or retraction. So my friends are not a component of me. right? So if I had a user/friends attribute, then that's not a component of me. Attributes that are not references to other entities are automatically, you don't say that they're components, right? They're just part of you implicitly, right? So you don't say is component about strings or numbers. The only attribute about which this is going to make any sense is when the attribute is a reference to some other entity. And that's a reference type attribute. So components, my spouse is not a component of me, right? My spouse has an independent existence separate from me in the world and in the system. However, an order's line items might likely be a component. Right? The line items would not have any independent existence outside the order. If I were retracting the order, I would want to retract the line items as well. So that's an example of something that you might say is a component. So these are the decisions you have to make. Now let's go make a few. Let's go through the process of designing a schema for an example system. And the example system I'm going to design is a social media system where people come together and post links to things that are interesting to them, and then they upvote links that they care about. So this is a classic, social media use case. So the first thing that we're going to have in the system are stories. A story represents something that has a location on the internet that you can talk about. And so our model for that is going to have 4 attributes: story title, story URL, story slug, and news comments. So this is an entity type in my system. And so story title is going to be a string. Every story is going to have one title. So it's going to be cardinality 1. Story URL is going to be a string. Every story is going to have one URL, so it's going to be cardinality 1. Story slug, this is going to be some sort of opaque thing that's used to make URLs. Like systems that do this kind of thing tend to make little unique identifiers, so this is the story's unique identifier. And then news comments is going to be a reference to the banter back and forth on my site about this thing. So after I post a link with a title and whatever, then Gary comes and makes a comment on it. That's going to be a reference to some other many-valued thing, which is all the different comments that have been made. So this is the logical part of designing a schema, right? I've thought about an entity type. Now we translate that into Datomic data. So for every single row in a little table like this, you're going to have a transaction, a bit of transaction data that goes into Datomic to create the thing. So the ident, story URL, that's the name of the thing. DB value type, db.typeString, that says it's a string. DB cardinality /1 says it's cardinality 1. DB ID, everything in the system has to have a DB ID. And all schema attributes must be in the DB partition. So db.partDB says this is a schema. I want this to be in the schema partition. You can treat this syntax around DB IDs as a magical incantation for now, and I'll explain it in more detail later. And then db.install attribute is a fact that's added to the system that also has a side effect that says turn this attribute on. So this is a required thing, and Datomic uses this to notice that this is a schema thing. Right? Otherwise, if you didn't have something like this, Datomic would have to look at every bit of data you ever put in and said, well, maybe this is schema related. I should go and do all the extra work associated with managing schema for this. So that's the thing that says turn it on. And those of you who are following along really carefully will notice that db.install attribute has an underscore in front of it, which means that this is actually a fact about db.partDB, not a fact about me. Right? That's reversing the order of navigation, just as we do with entities. That's really a technical detail from a schema perspective, but just sort of stitching things together. So we would have a piece of data like that for repeated 3 more times. One for story title, one for story slug, one for news comments, that specified the right things for each one.
Would it be possible to have a natural ID field as well, that increments 1, 2, 3?
So there is not a natural ID field in Datomic that increments 1, 2, 3. There are implementation strategies that you could use to do that, and I'll show you that when we talk about transaction functions after lunch. A lot of times where people do that, bear in mind that the entity ID itself that Datomic assigns is itself an auto-incremented number. So if you just want a number that's unique within the database, Datomic makes one automatically, and it's more efficient than anything that could possibly be made outside of the system. But if you want a number that's not only auto-increments, but that you have control over, like start at 1,000 and start doing this, then you're going to have to make that yourself. And we'll see strategies for doing that later. Other questions while I've...
Is the transaction ID unique across
Datomic's IDs are unique within a database. So we'll talk about uniqueness again when we talk about transactions. We'll talk about making things that are globally unique and how to do that.
And the transaction time is unique as well?
The transaction time is unique within the database. Right? Now, understand that the time is a number, like 1011. The wall clock time at which the transaction happened, that only has a resolution of milliseconds. So it's possible that that would not be unique if you had a system that was really cranking and somehow it was able to get 2 transactions through in the same millisecond.
Is it geometrically still at the date added field, or do people get the data insertion from the transaction ID?
So the question was, is it idiomatic to continue to add things like a date added field in something like Datomic? Definitely not. You definitely would not want to do that. I don't want to go in detail about that, but we will when we talk about the time model, and this afternoon we'll talk about in detail about why you wouldn't want to do that and why it's a problem in systems that do it today. I mean, why you want something like Datomic's time model instead of a date added column in a database. All right, let's do this exercise a couple more times. We're going to have users in our system. Users are going to have first names, those are strings, cardinality 1. Last names, strings, cardinality 1. Email, we're going to have as a unique identifier. So we're intending this email to be, they have a unique login to the system that's based on their email. So we're going to have that be unique. And then we're going to have upvotes, which is going to be a reference to many things that they voted for. Upvotes is going to be a reference to stories. Right? They can upvote stories. Where in the schema does it say that upvotes have to be references to stories? It doesn't. Right? This is a dynamic database. This is a powerful choice that you're making here to say that relationships can be to anything. Right? We've already been down the world of relationships can only be to certain things. What is that? That's foreign keys in relational databases. If you need a system that works like that, you already have that. Right? This is a more flexible system. It allows you to do more things. It also requires you to be thoughtful. And we're going to have comments. Comments can have a body, which is just the text of the comment. They have an author, which is a reference. The reference that a comment author points to is presumably what? A user. Right? Again, Datomic doesn't say anything about that, but presumably comment authors are going to be users, not stories. Right? Stories are not entities that can go out and comment on themselves. And then comments have a news comments ref. One of the things to notice here is that when I'm doing my schema design, I think in terms of entities. I think in terms of there are stories, and there are users, and there are comments. But these collections of attributes are conventional. There's not a separate comment table. There's not a separate user table. It's up to me to make things that have these attributes. I can make anything I want. Right? This is like the difference between dynamic typing and static typing. I can make an entity in the system that has any combination of attributes. I could make something that had a user first name and a comment body. I probably shouldn't, but I could. In particular, this allows you to have attributes that are used in multiple contexts. So the comment attribute can lead from a story to comments about that story, or it could lead from a comment to comments about that comment. So if you have 2 different entity types in the system, both of which really have a relationship with the same semantics, then you can use that exact same name. Now, to be fair, this is something that people overuse all the time. So we had a question on the Datomic mailing list just this week where somebody said, well, I have 10 different kinds of things in the system that can all have names. So should I just make an attribute called general/name and have all the different things be in the same attribute? Probably not. Right? Probably those names have different semantics. Right? The part names look like this, and the human names look like that, and the order names look like that. They probably have different semantics. They probably have different meanings. But that's up to you. That's a modeling choice. The way I go about modeling when I'm designing a system in Datomic is I draw an entity relationship diagram that shows the entities. Then I pick the attributes out of there, and then I define it. And as an example of that, here's the one that we drew for Music Brains. So what is it to be what is it to have music? Well, you have releases. These are releases of music. There's lots of facts about them. Releases are on a medium, so vinyl or CD or whatever. And it's the medium that has tracks. Right? Releases don't logically, they do, but they have tracks by way of going through a medium, because they might have different tracks on different release media. Tracks have artists. Artists can also be reached directly from releases, right? Releases have artists. And then there are a couple of sort of, less important attributes, at least when I don't really care about the labels. There, I just made a value judgment. Sorry, labels. But the music labels, right, they have their own thing, and you can go find out about them and so forth. But this is how I do schema design in Datomic. And when I'm done, each one of these little lines in this table is going to turn into 5 or 6 datums that I put in the system that look like that, right? That's actually, the DBID is not really a datum. That's setting the E for a bunch of datums. That's 1, 2, 3, 4 datums. An ident, a value type, a cardinality. Tell me that I want to install it. So I'm going to make all the data like that and put it in the system. You can view the schema in the console, and you can see all the pieces that we just talked about. So if we go out and jump to console, you can see all the pieces that I was just talking about. You can say that release, abstract release, let's look at, name of the release. Name is set index to true. Its cardinality is DB cardinality 1. Its value type is string. Its identifier is release/name. And the viewer here, this schema viewer, makes a presumption that you're going to use namespaces to kind of define entities. Right? That everything in the country namespace is about country, everything in the artist namespace is about artist. But as I've already said, you might have attributes that span different kinds of entities. So that one-to-one mapping is convenient, but it's not necessary. I think that doing this there's no doubt that you do have to do a little bit of data modeling. Right? And I think to get the power of databases, you have to do data modeling. Right? You can't, if you're using a database that has no data modeling in it, you're not really using a database, you're using storage. And that's fine, and that's useful, right? I like to store things and be able to get them back later. And if I don't know anything about them, useful, then I can't do any data modeling. Then storing them and getting them back later is a perfectly legitimate thing to do. But for me, the purpose of putting something in a database is to have more power than that. The exercise of doing data modeling in Datomic is really nice because you have this very smooth transition. You can take your picture, right, and almost mechanically say, OK, given my picture of these entities are related to each other and they have these attributes, manufacture the schema that you need. And that is, in fact, what we're going to do next. So your job in the next lab is at least 50% pencil and paper, not on the computer. Right? Go and find a hammock to sit in while you think about this. I want you to pick a small domain that you know well. Let me just uber-emphasize the word small. Right? If you have a domain that has 5 entity types in it and each of them has 10 attributes, that's 50 schema elements to define. That's too big for this. You might make a slimmed down, goofy version of that only has 2 entity types and 4 attributes each. It'd be nice if it has just enough complexity to have a relationship, orders to line items or something like that. Pick a domain that you know. Draw on paper the entity relationship diagram. Right? This entity has these attributes, and some of them are relationships to another entity. Then, the challenging Datomic part, convert that to Eden data. There's a bunch of sample Eden data in your, actually the link at the bottom of this page, links to a whole collection of Datomic schemas, any one of which you could look at to get examples for what you have to do to define a schema. Having converted that stuff to Eden data, transact it into a database. So again, you can look at the Day of Datomic examples. The call for transacting data into a database is just transact connection data. Transact that data into the database, and then view your schema in the console. Make sure that it got in there. Take note that when looking at the console is not live, so you have to refresh the browser to catch your changes. So you'll put it in and then go, hey, I don't see my changes, and I'll say, refresh your browser, and you'll see the changes. All right, so that's the lab. We will do this lab and then break for lunch. I think I'll double check what the schedule is with the other room and make sure we're coordinating well, and resume at 1 o'clock. Thanks.